and cosines. We're going to graph sines and cosines today. We're going to shift sines and cosines tomorrow. We're going to graph and shift tangent on Wednesday, tie everything back together Thursday, and quiz out of this stuff on Friday. That way when we get back from break, we'll graph all of the inverse trig functions, solve trigonometric IDs, solve trigonometric equations, and do some trig modeling. So there's a big, big trig chapter here. Graphing is a little bit easier than the rest of the stuff. The rest of the stuff gets to be a nightmare.
So this week should be.
This week should be pretty good.
But the week after spring break happens.
Second half of this chapter is very difficult. I'm not going to lie. Second half of this chapter is very, very difficult. Actually, I shouldn't say the second half. It's section 4.3 to the end is very difficult.
Right.
6, maybe. So here's what I want to do. Again, I want to look at where we started out with that real basic sine graph. When x was 0, y was 0. This is for sines. Then it went to pi over 2, pi, 3 pi over 2, and 2 pi. These are, looking at these as being my quadrantals. Then it went from 0, 1, 0, negative 1, and 0. Again, your graphs are going to all look kind of the same to start with. You're cutting yourself into halves and then into quarters. A couple of quick definitions. The maximum height this curve makes is called the amplitude. The time it takes one cycle to go through is called the period. The period is the length of the curve, how long it takes to go through one through wave. The amplitude is how high up the wave goes, or how low the wave goes. There's a couple of things that's going to happen here. We're going to have the form of y equals a sine of b times x. Where the absolute value of a is your amplitude. And for sine, for your period, you take 2 pi divided by the absolute value of b for your period. How long it takes to go through a cycle. And then a sine bx mirrors the same thing for cosines. A cosine b of x. A's and b's mean the same thing. Tomorrow we'll reintroduce you guys to the h's and k's, your horizontal, your vertical shifts with these as well. All right. So let me show you the cosine graph. We'll probably never use trig graph paper again. And again, this is all going to be stuff that we're going to do without calculators. Again, if I just want to look at the generic cosine of x. What's that? Amplitude?
No. Y equal a cosine
bx, yeah. Y equals a cosine b of x. That's just the generic form. y equals a cosine b of x, yes.
He's talking about the one at the bottom.
I know, I'm just showing the generic cosine of x. A is 1, b is 1. So if a is 1 and b is 1, again, cosine, when you're at x equals 0, cosine starts at 1. Cosine starts the curve at 1, goes to 0, negative 1, 0, 1. What we're doing here today is basically plotting the parent functions of what we're going to be doing tomorrow. Okay. A, B, and x are all part of the parent functions. So the little bit of the difference thing here is, as long as we understand how to identify our amplitude and our period, everything else falls into place. It is very easy to work with this once you're able to set up your amplitude and your period. Which leads us to all of this, which I don't think you need to worry about, because it breaks it down to something much easier as this. Again, a sine of bx and y equals a cosine. The absolute value of a is your amplitude, and your period is 2 pi over the absolute value of b. Basically, again, your amplitude is how high up and how low things go. Your period is how long does it take to go through one cycle. Very exciting. Yes. Wait till you see tangents. So let's look at this. Y equals 2 sine of 4x. Whenever I start these things, I'm always going to identify my A and my B. Tomorrow we'll identify A, B, H, and K. So what's my value of A here? B. Good. A is 2, B is 4. That means that my amplitude is the absolute value of 2. What's the absolute value of 2? 2. My period is going to be 2 pi divided by the absolute value of 4, which is pi over 2. So here's how you graph this. Again, the easy one is your amplitude. The amplitude is 2. That was easy. The period. The period is where things get weird. It's going to be pi over 2 at the end, and it starts at 0. What's halfway between 0 and pi over 2?
Pi over 4.
Good. Pi over 4. What's halfway between 0 and pi over 4? Pi over 8. What's halfway between pi over 4 and pi over 2? Here's an easy thing to think of. You just figured out the halfway point being 1/8, right? Isn't this 2/8? So this would be 3/8. 3 pi over 8. Okay, once you're able to figure out the fractional amount that's between 0 and the halfway point, that's the simplified fraction, if that makes any sense. 1/8, 2/8, 3/8, 4/8, that's how it's breaking itself down. Okay? That'll be the most difficult part of all of this, being able to work with fractions. Again, since this is a sine curve, it always starts at 0. It goes to the a value, which is 2. 0, the opposite of a, and 0. There's your curve. Like I said, all of these curves are going to look the same unless the a value was negative. If a value was negative, which direction would it go first? It would go down first. Okay. The tricky part of these things is just going to be figuring out those those checkpoints for your periods. Yeah.
And then cosine will always start at the top.
Yep. Yep. Cosine will always start at 1 or whatever the A value is. If it happens to be a negative A value, then it just starts below, works its way up, and goes down.
Oh.
Okay. It's going to be it's relatively straightforward. Okay. The trickiest part of all of this, guys, is working with the fractions here. Okay. Working with the fractions is going to be the trickiest part. Okay. Oh, was that one? Y equals 1/3 cosine of 2 pi. A is 1/3, so therefore my amplitude is, my B value is 2 pi. So what's my period then? Remember, the period is always 2 pi divided by B. So my period here is 1. It's 2 pi divided by 2 pi. Okay. What's halfway between 0 and 1? What's halfway between 0 and a half? Half and a half, yes. And then we have 3/4 here. Cosine, A is positive, where does it start at? Starts at A. What's the A value? Starts at 1/3, works its way down, and works its way back up. Again, what we're working on here today is we're working on the parent function of stuff we'll be looking at tomorrow. Tomorrow, you'll have it look like this. Okay. Yes? Tomorrow, you'll have that. K is -4, and H is correct. So that means what do I do to each point? Shift over pi and perfect. That's exactly what's going to happen. All right. So tomorrow when we get to this, we still plot the same things: the A, H, and K. We still plot the A, B. Excuse me, the A cosine of B, and then we just shift all those points. All right. There's a couple other little things I want to show you that happened in here. Are these little maximums and minimums. Again, I'm not worried about sign graph paper. What's that? I always think that I want to use them, but then I don't. Because the more, I always try to put them in, and then I keep thinking to myself, you know what, I won't use it. And then sometimes I think, maybe I'll use it. I want you to be able to draw it, so there's no reason to. Here, what's your A value? What's your B value? So what's your amplitude then? Yeah, oops. 1/2. What's your period going to be? 2 pi. I want to talk about the intercepts. When we're looking at the intercepts, we're looking at the intercepts on the x-axis. All right. When my period is 2 pi, that's the easiest one I can graph, because it's just basically plotting the quadrantals. This is a sine function, so where does it start? Starts at 0. Goes to what? Okay. What are your intercepts?
Pi and 2 pi and 0.
Yep. 0, pi, 2 pi. What's your maximum value? What's your minimum? Good. The maximum and minimum values, what is the highest point it gets to? Half is the lowest point it gets to.
So it's just like.
It's just, what, does it get much more difficult than this?
Today, no. Today it really doesn't. Tomorrow is when the weirdness happens. And I'm going to show you just a couple of examples of kind of the weirdness, so you get the idea of where things are going to, what things are going to do when they're reflected and whatnot. The trickiest part of all of this is when your period is a weird fraction. That's usually where most people have the issues. Right? That's usually where most people are going to have problems. So let's try a couple like that. Let's see what happens. Bless you. Let's see what happens. Let's see. Y equals -2 cosine of 1/2 x. Let's try a little bit of a weirdness here. What do you think your first steps are to do? Yep, figure out your A and your B. Always find your amplitude and your period first, guys. Cannot stress that enough. So if my A value is -2, what's my amplitude? 2, good. Remember, your amplitude is always the absolute value. And now my period is 2 pi divided by 1/2, which is? Good. Remember, whenever your B value is fractional, just multiply by the reciprocal. It's 2 pi. It'll work every time. Okay? It'll work every time. Draw it out. Going out to 4 pi. What are the other breakpoints we have to worry about?
Pi, 3 and a half.
1, 2, and 3.
Yeah. Nice when it works out this way.
It is nice. It is nice. I like that.
Amplitude is 2, so it's got to go up to 2 and down to 2. It's a cosine value, so the cosine always starts where? At the A value. What is our A value? -2, so where do I start this? Then where does it go?
That's tricky.
Cosine always starts at the A value, goes to 0. The opposite of A, back to 0, and then back to A. Always follows that pattern. Always, always, always. It's kind of nice with these things that there's not much change to them.
That's just a number.
Yeah, that's really all it is. It's really all it is. And like I said, the weird part of these things are going to be when you have some weirder fractional answers. Graph that.
Oh, that's
All right, so let's see here. In this case here, you had an A value of 2/3, a B value of pi over 3, which means your amplitude is 2/3. Your period is 2 pi over pi over 3, which is 6. Yeah. Okay?
That's not what
It's just 6. Because whenever you have a fractional B, whenever you guys have a fractional B amount,
Oh, shoot.
I'm gonna bring a bar of soap.
I didn't say anything.
I can read lips.
I said love you, love you, and love you.
You wanna read mine? I'll call you out on it.
That's
Anyway, whenever you have a fractional B amount, just do this. Take 2 pi, multiply it by its reciprocal.
yeah.
It works every time. It'll work every time. Okay. I'm sorry, Mike. I had to do it.
I have a side note.
And I'm sorry I missed out on Pi Day with you guys. It would have been oh so much fun.
Wait, when was
It was Friday, was Pi Day, Cassie.
I thought the 14th was St. Patrick's
No.
Day. I didn't know it was the 17th.
No, you.
I know there's such awesome days they have so close together. You know.
My brother.
So again, here you've got to get your halfway points. So
Wait, for National Pi Day, is it like PI or PIE or both?
Pi. Yeah.
It's bad.
March 14th.
But
3.14.
do some people celebrate Pi by eating pie?
I think so.
Yeah, of course you do.
They have the pie recital contests.
Next year, because isn't it 3.1415? It's 3.1415.
What's the coordinate of pi?
What's that?
What's the coordinate of pi? You know, like the location coordinate that I was talking about? Like 3.14 north, 3.14 west?
Oh, I don't know.
That'd be interesting.
Next year for Pi Day, 3.14.
That's, it's like we should try and see to get married.
But when you tell a joke,
So just for fun, what this is going to allow you to do tomorrow, again, here's your A values at -1/2, your B value is 2, your H would be -3 pi, and your K value is 1. Remember, H's are always opposite, K's are the same. So when you go to graph this, you know your amplitude is positive 1/2. I know my period. What's my period if my B value is 2?
pi.
Yeah, good. My period would be pi. So here's what happens. We graph it out. Notice that, oops. One thing I want you to notice is that we have a horizontal shift of how much? What's your horizontal shift? -3 pi. So that means it's going to be moving to the left quite a bit. Do you agree? So what happens is, I'm going to kind of over-exaggerate my XY grid. I'm going to plot my parent function. Starts out at pi. Put in your breaks. It's a cosine function that has a negative A value. Where does it start? Okay, -1/2. And then it moves up. So it looks like that. Do you agree?
Yeah.
Now, then I just shift each individual point. Remember, when we did parent functions, we would just do a dotted line. So this point is no longer at pi. It's got to move to the left 3 pi. So here's 1 pi, 2 pi. Well, sorry. You just mark them all off, move everything over, and then it has to go up. Again, it's not going to be that complex of a scenario. Once you're able to identify and plot these things, everything else falls into place. It's just a matter of working with the
That's a
fractions.
really big shift.
It is. All right. I was just trying to have a quick example of where we're headed towards. I want to work with.
Cross 5 quadrants.
Yeah. I want to put I want you to graph 2 more, and then we'll call it a day. Graph these 2 real fast, please.
What about the,
Hold on, guys. 3 cosine pi over x. I'm hoping you had an A value of 3 and a period of 2. You guys agree on that? Amplitude is 3, period is 2?
Yeah.
All right. So here's 3, 2, 1, 1/2, 3 halves. No, don't put your calculator because that won't be right tomorrow. Because you won't be able to use a calculator on this quiz.
No, quiz is Friday.
A value is 5, B value is 3 pi, which meant that your period was 2/3. This is where people freak out. Oh my God, I don't know how to work with a fraction. What's the half of 2/3?
Third. The Death Star.
no, it's just, no.
What's halfway between 0 and 1/3?
1/6.
What's half between 1/3 and 2/3? 3/6, otherwise known as.
Oh, yeah.
Yeah, I knew that.
Those are just fractions that don't go in.
Stop whistling.
Yeah, Brian.
Again, sign value, A is positive, starts at 0, works his way up. Sam, you all right?
So how do you get the period?
Period is always 2 pi divided by b.
Oh,
It was, b was 3 pi, so you wind up with 2/3. Okay. Not so bad? Let me give you a few of these to try.
Mr. Murphy, should I grow a beard?
Sure. I have 5 graphs for you and 6 equations for you to write out. This is on page something. 836.
This is our homework?
Yeah. On page 836, I want you to start on number 36 through 43, but do not do the tangent ones. So there's 3 tangent ones you don't do.
Oh wow, so it's like 4 questions.
So it's 5 graphs, basically 36, 38, 39, 41, 43. And then 44 through 49, I want you to write the equations out. What you're doing there is you're writing the equations given the amplitude and the period for sine. Those are all for sine. Okay? So what happens here is if you know that your amplitude is 1, what's your A value? 1.
Or negative.
It could be or negative 1, okay? But I do believe where A is greater than 0 and B is greater than 0, so that way they always have a positive. Okay? Okay. So if your amplitude is 1, your A value is 1, and your period is 5, you have to figure out what your B value is. How do you find the equation for our period? It's 2 pi over what?
Absolute
B,
value
F
of
value.
But it's all, B's always, for these parts, A and B are always positive, okay? So you don't have to worry about the absolute value of that. So here, remember that the period is going to be equal to 2 pi over B. Well, if I know that the period is 5, how do I figure out what B is? That's what you have to solve for, okay? So you're just working backwards with those guys, all right?
And what are
836.
So do you need 5
5 graphs above it, and then 43. Okay? So you've got 5 graphs and 6 equations to write out.
Get at it.
Yes, sir. For B? Well, if B was equal to 2 pi over 5, what do you get then for your period? Yep. All right.
Yes.